Hello, and welcome back to another coding session with Mr. Jacob. Today I want to implement something together with you that I have read about like a month or two ago, which was in my backlog for when I wanted to implement something using graphics and animation and stuff like that again. I'm talking about a simple game or graphical update render loop which properly uses fixed time steps, which actually is a neat idea. I've never thought like that about because I'm not really in this general topic besides my free time. But what I'm talking about is I want to have some sort of mini framework which I can use to quickly create some sort of graphical applications in Rust. And I thought about using this library here, which is called Pixels. And what it essentially does is it abstracts away all the hardware kind of stuff drawing and uses or gives you a simple 2D or a simple array of bytes where you can put color byte values in, and it will print them into your window. And doing that as fast and as good as possible using hardware acceleration and all kinds of stuff. But doing that, I realized I need something else. I need some sort of game loop, which usually consists of something. Let's quickly init the project here and let me see if I can tell you what I'm talking about or sketch it out here. Which would usually consist of something like we have a loop and then we do some sort of update game state. And then we will render the game state. And this is more or less our rendering loop. So what we want to do is we actually always want to call an update on our whatever game state or GFX simulation state or whatever. And then we want to render that state. And we want to have those two steps separate because they can actually take different amounts of times, and it is always a nice thing to have those separate. But the problem is we need to know somehow how long this takes. So what we need is we need to know how much time has passed between those steps in order to properly calculate how far we need to advance our game state or our animation state or whatever. So think of a simple object moving from A to B over a certain amount of time, like for example 5 seconds. We want it to go from here to here in 5 seconds. Then we need to know how long each frame took, how long each of those loops took to advance it correctly along those lines, because on every system this might take a different amount of time. And this article here actually, actually explains something that is a really neat idea. It's like I will link it down in the description. It describes all different kinds of ways to do that and the pros and cons of that, and then reaches the final thing here, which essentially is the idea of always having a fixed time step, like we always updating 120 times per second. And we are then adapting those time steps based on the render speed we can achieve. So the idea is that actually the whole interval, like rendering and updating, of course, everything together, the time that has really passed, the time that we are measuring, that we are needing to produce one frame, is actually kind of producing time. It's producing real time because it is the time that has passed in the reality, and that our update cycles consume that time. And we are calling updates as much as we have produced time. So this is actually a really neat idea, because otherwise this would involve quite some amount of math that is quite complicated there. And the idea is that I can do something like I want 120 updates per second. And it will automatically kind of adapt the amount of updates it does on the real time that has passed, so that in the end, the amount of time that has passed from my programmer perspective of view in every update call will be 1/120th of a second. So I can always assume it has passed 1/120th of a second. There is, of course, the possibility that my updates take longer than that, and we will see later on how we can handle that. Because then, of course, I can't have 120 updates per second. If the function takes longer to run than 120th of a second, then we have a problem. But usually, this actually is possible to do with, for example, certain techniques, or with using less of an update speed or stuff like that. And I want to actually implement a generic way for me in the future to use of this neat little thingy here, so that I don't really have to worry about, in most situations, in my update functions, to use some sort of dynamic how far along are we system to do stuff. I can just assume that the given update rate is really done by the system, and this is really simple, and therefore I thought I would want to implement that. So let's go ahead and do that, and maybe we can actually kind of use that. But let's think about how we would implement this. I've called it pixel loop because I want to use it for pixel drawing in the end. So let's maybe just call pixel loop here, and let's put in our desired update rate. For example, 120 should be configurable, I guess. And then we can simply put in maybe print line update, and maybe put in another function. We will see what arguments we need to pass to that function later on, but for now they are just argumentless. And let's call this one render. Yeah, something like that. And maybe we could, one of those should maybe return. Why did it remove those? Not sure about that, but wait, what? Why did it? Why did the formatter remove actually the braces? I'm not sure I like that. Okay, that's better. So now let's implement the pixel loop function. So pixel loop, and pixel loop should take, what should it take? It takes the update FPS, which is a usize, I guess, or maybe a U64. Let's make it a U64. Why not? No, it's a usize. And let's then do something like we have update here, which is a simple function not taking any further arguments. Come on. And we have render here, which is a simple function not taking further arguments for now. And what we now need to do is we need to do something like we have our loop here, and in this loop we want to do something like while there is time, or let's start with the render here. So we are doing render, and every time we render something, we need to add to some sort of accumulator the time that has passed since the last render. So maybe let's call that dt, and let's do something like and we of course need an accumulator. Let accumulator, and what will the accumulator be? Most likely it will be a duration, I guess. So let's for now do something like duration new 0, 0. And we need, of course, duration. So use std time duration. Not 100% sure. Okay. And what we want now is we want to add to this accumulator dt. And the time that has passed will need to be something like, yeah, I guess we will need to do something here like last time equals current time and and current time is something like instant now, I guess. So let's use time is instant in time as well, would make sense. Yeah. So, and we need, of course, those variables, and those variables need to be tracked across the different loops as well. So we have current time, which we can actually initialize with instant now, and we have last time, which we initialize with instant now as well. No, we initialize it with current time. I guess we want them to be identical at first. So let's see. Maybe this is a problem because we are somewhere then dividing by 0, but we will see. And all of those need to be mutable, I guess. Okay, so now last time is current time, and current time is the new time, and then the delta between them would be, can we just subtract durations from another? I guess we will find out. So current time minus last time should give us now the delta time between frames. So every time this loop runs, it calculates how long that took and calculates the new delta of how long that actually took. I'm not 100% sure we want to do this at the end and not in front of, because I guess I want to supply this value to the functions maybe, just for them to be able to access them. So yeah, let's see. So I guess we can do that up front, because then it will simply be the last loop, won't it? Yeah, it will then always be the last loop, or in case of the first one, it will just be a fraction of a second, which solves our division by 0 problem as well. So that is kind of nice. Okay, so let's see. Now that we have that, we can actually do something like while the accumulated time, we remember the whole rendering cycle produces time while the update cycle uses it. So while the accumulator is bigger than the update FPS, so what we need here is we need something like update FPS in, or update dt, the delta time of each update cycle, I guess. And this one would be, what would it be? It would be a duration. So a duration from, can we do something like, yeah, from nanos. And what we actually want to do is, a nanosecond is a billionth of a second. So a billionth of a second. So if we are dividing a billion by the update FPS, so we need this one as an F64 and this one as F64. And if we then round that and put it in there, what does it want? I guess U64 as U64 makes kind of sense. Then this should actually be our update delta time. Yeah, I guess so. And what we should actually do is something like, or if you put in there an update FPS that is 0, so maybe we should check that just for the sake of things. So if update FPS equals 0, then we simply do something like panic FPS for updates, designated FPS for updates must or needs to be greater 0, something like that. Because it can't be 0. That doesn't make any sense. So now, while our time is still bigger than the update DT, and let's remove those braces there. So while the accumulator is still bigger than update DT, what we do is we call update. And what we do is we say the accumulator is now update DT is less than is now lowered by update DT. So we are actually using up the collected time, kind of. And I guess this is more or less the implementation of the loop. And now let's see what it has to. Variable current time should have snake case. Indeed, it should. Why did I guess because in the pseudocode I read before, or I glanced at before, it didn't have. So I kind of did that. Yeah, I guess this should actually do. So what is this? Value assigned to last time is never read. Wait, value assigned to last time is never read? Did I do something wrong here last time? But I'm reading. Oh, yeah, because the question is here, do we even need to initialize that? I don't think so, because we are always initializing it. Yeah. That kind of makes sense to me. Yeah, so I guess let's see if this compiles and what it does. Cargo run. Okay, it's calling render and render and render over and over again. Not calling update. Yeah, I guess because render finishes really fast. So let's do something like more realistic here. STD, where is it? In thread? Sleep, duration from micros, millis, whatever. Something like the usual 60 divided by 1 divided by F6 divided by 60. So this should be the amount of our update. No. Wait. Let me think about this quickly. If we are having something like a usual update rate of like 60 frames or so per second, then this would be around 16 point something milliseconds. So maybe we do something like one render cycle really takes 16 milliseconds. So we are simulating that. So let's see. Okay, so we seem to mostly get 2 updates for 1 render. 2 updates for 1 render. Wait, what? It would be nice to be able to see a little bit better the timings of this stuff. So let's see. Maybe we can somehow implement a rudimentary timing calculator thingy here. So maybe we can do something like let updates called equal 0 and let renders called equal 0 So each time now the update is called, we do updates called and add one to that. And each time the render is called, we might do the same for render is called, and we can't, of course, do that because they need to be mutable to be able to do that. Now we are doing that, but what we need as well is something like if a time of whatever, 1 second, 2 seconds, whatever has passed, we want to calculate those things up, and therefore we need to know how much time has passed. So what I actually want to put into this functions is the delta time, which is a duration, I guess. Yeah, why not? So it's the delta time and it's a duration. And is it a duration, or I guess the duration only holds those two values so we can copy it. We don't need to reference it. So what we actually then want to do here is we want to put the delta time in here, but the delta time for an update is wait. Is this now the delta time between? Oh, that's actually kind of interesting. I guess an update does not get the delta time because an update is called at a constant delta time. That's actually why we are doing all of this. So render is getting the delta time. So what we now can do here is, wait, where's the problem here? Pointer fn found, wait, what did I do? What have I broken here? The render function now takes a duration. The update function does not. So the first one is the update function. So why is it broken like that? Give me the what the hell is happening here? Arguments to this function are incorrect. Expected fn pointer found closure. Okay. Closures can only be coerced to fn types if they do not capture any variables. Yeah, we could actually now change this fn here to be using a generic and an fn mut or something like that, because we need now a type there that can actually capture those variables. The question I'm thinking about now is if we really want that, or if we want to somehow transport a mutable state into those functions. And I guess that would be a better idea. So maybe we want something like, let's do something like struct state, and let's put those in here, and of course then they just have a type like this and a usize here, and let's remove that, and let's remove that. And what's the problem there? I guess this is the problem. And then we want something like we want to simply derive default for the state so that we can easily initialize it, and then we will do something like let state equals state default, I guess. And then we will do something like we will put the state in here, I guess. And then those functions will get the state maybe and can do something like this, and I guess they get a mutable reference to it. Let's see. So yeah, this is of course all broken now at the moment. So what we then need here is something like S, which is any sort of state thingy that we want to put in there. And I guess we are owning it. So it should be possible to do something like mut state. Should be able to pass that. If we change this one to be taking a mut s. So yeah, and this one takes a duration and it takes a mut s, and it takes a duration. And now we should be able to pass in here mood state as well. And this we can't do because, yeah, mutate immutable variable state. Why is it immutable? Do we need to do something like, oops, do I need to pass it as a mutable here? No, wait, this does not make much sense to me. Do I need to do it like this? Okay, it seems I need to do it like this. And then what's wrong here? So now this thing is no field updates called on mute integer. Why, wait, why integer? Wait, what? Expected use size found state. What did I, oh, I just passed them in the wrong order. So what's the problem here now? Closure is expected to take two arguments. Yeah, that's right. We want the dt as well. Okay, so now we should have been able to actually pass a state in there that we can manipulate. We will need that later on anyway. So let's see. And now we get the dt. So we can have something more in our state. We can have something like time passed, which is a duration. And we should be able to do the following, I guess. We should be able to do something like s dot time passed plus equals dt. And if s time passed is bigger than duration from, let's do sex1, or maybe 2 to smooth out the values a little. If more time than 2 seconds has passed, what we want to actually do is we want to print line something like update FPS is, let's see, let's format this with 2 points after the 2 decimal points, two decimal numbers. And this would be something like s dot updates called divided as f64. Wait, it would be updates called divided by 2, I guess, because we have two seconds there. Yeah, makes sense. And we want we want render FPS, which is renders called. And what we then want to do is add semicolons here, and we want to do something like s updates called equals 0, as renders called equals 0, and as time passed equals duration default, which most likely will be a 0 duration. Yeah, I think this should actually do it. Let's see. Oh, wait. And we for now remove those render and update calls. Okay, so I must say I wouldn't have expected that. Did I do something wrong with the calculation? Because those values don't really match up, which is kind of strange. So is it because our frames, what is actually 1 by 60 times 1000? So 16.6 milliseconds, something like that, yeah. Maybe we are sleeping a little bit too long here, so that we can't actually reach the desired the desired interleaving, which can of course happen, but we will see. Yeah, this looks actually better. Let me reduce this from 4 seconds to like 2 again, or even let's make it 1. So not really much smoothing at all then. Yeah, this looks actually better to me. So now yeah. Yeah, this actually really looks better. So this seems to work out quite nicely now. I guess this is something we can work with. So essentially, we do not really care about the amount of time it takes to render. So if we, for example, have something like, let's make this even smaller. Let's make it like we want a rendering frame does only take 4 milliseconds. So now we should actually, yeah. But what's really relevant here is not the amount of rendered frames, but it is that we are actually updating at a very constant 120 with a little bit of wiggle, but with a very constant 120. So if I'm going back up here, where was it? Where we had this strange render values here, we still had a quite constant update value of around 120. And that's what's important, because in the end, we don't really care how fast or how slow the system is able to render our frames. We wanted to call our update function in a very constant manner. So yeah, I already like that. This is working out quite well. So let's see, maybe we could now try and make this, oh no, we need to handle one more thing, because let me show you something. What happens if we do something like, we now have an update function which takes a really high amount of time. Like let's say it takes 25 milliseconds, or maybe even 100. Let's say it takes 100 milliseconds for each update. So what we now have is we have quite some problem, because now we are only calling our we are first how should I explain? The problem now is, as you can see, our program has sort of crashed. Or yeah, it as you can see, something very bad has happened here. The problem is we are now getting behind in our schedule, because we are assuming that we can call the render function as fast as needed, the update function as fast as needed to handle those 120 frames per second update interval. If we can't, with each calling, we are going further behind in real time. So as you can see, this should update every second, but in the end, this is going into what's called in this article a spiral of death, because we are accumulating more update. We are accumulating more time through the updates than the single update should actually take from the update cycle. So what happens here now is, in our update function, where is it? We are actually accumulating more of the time during this time interval for each run, for each loop. Then each of those update calls here is taking from the accumulated time, because we are always only taking the fixed amount of time. So this is a problem, because essentially once we are in this state, we will never get out of it again, and it will accumulate up and kill our program. So what we need to do, and what the article actually tells us to do, to have some sort of escape hatch. To have some sort of escape hatch which will cause the system to normalize again. So what this means is that we are actually, in our calculations, we are maximizing the frame time. So the time that actually is added to the accumulator, that this whole cycle takes, even though if in reality it takes longer for whatever reason, we are not putting this into our calculation. We are simply using a fixed amount of breakout value there, which essentially causes the system to run slower than real time for however long time it takes to catch up. If it, of course, is always slower than real time in the updates, then we have another problem. But then our whole game has a calculation problem and can't run properly. It will never run properly then. So to just kind of fix this for a moment, where whatever we are doing in our update function or whatever may have happened on the computer at this moment in parallel to our execution, we may need to accommodate for certain peaks in the frame time, and this is actually, or in the update calculation time, and this is actually where this escape hatch comes in. So we are always limiting the amount of real time we are advancing. So we are limiting then the amount of real time that we can kind of jump forward. And in this case, this is 250 milliseconds, which in our update scenario would actually be something like, what is it? 250 divided by 8 would be 30 something update cycles. So I'm not sure if this is actually a proper, if this is the right value. We may want to make it configurable, but for now, I guess we will do something like, if dt is bigger than duration from, let's see, milliseconds. How many do we want here? For my taste, 250 is a little bit long. I guess I would like something, maybe we could base it on the updates we need to count per second. Maybe we could adapt it to this value and just say it is not allowed to take as long as 10 times that, but for now, maybe just 100 milliseconds. And if that is the case, then dt should be duration from millis 100. And we can't mutate that, can we? So would it be a good idea to escape hatch if updates take too long? If update calls take too long, in order to not spiral into death. And maybe, as I'm now using the kind of the wording from the article, maybe I should quickly just take the URL here and put it here. Inspired by... Let's just put that there so that we always know where to look all this stuff up. So now, even though we are taking a lot of time for each of our update cycles, we should actually not spiral into death. So let's see. Oh, yeah, now we have another problem. The program is running, but we are, of course, now simulating less real time than real time has happened. So everything will be slower from a update perspective. So if we actually have something here like that, it will take us a lot of time to reach the real second kind, so to speak. So maybe we should activate those things here again, so like that we can see now what happens. But so now, as we can see, it is not calling updates over and over and over and over and over and over again, but it's only calling them, and there was our first second kind of which passed. It is only calling them a limited amount of time before rendering again and then stepping back and doing the same thing. So what we are actually doing here is now we are kind of reaching that, and we are limiting our frames per second, and everything is going a lot slower now, but we are not spiraling out of control. And this is actually This is actually a good thing. So let's comment that in again, and let's assume our updates, or let's maybe make our updates a lot slower, a lot faster. Like they take time, but they only take like 4 milliseconds. And now everything, I've forgotten to make a comment here again, and now everything should be back to normal. Yeah. So and as you can see now, we are still having a quite constant amount of rendering cycles. Yeah, for now I'm kind of happy here, I guess. This seems really minimal, and it does mostly exactly what I wanted to do. So yeah, let me take a really quick break here for myself, and then maybe we can take a look at how to get the pixels library into that, and how to integrate that with a simple event loop to open up a window, put our pixels on there, and then do something like moving one pixel around or something like that, just to see something graphical here now, and then we are fit to work with that, I guess. So see you in a second. Yeah, so there I am back. For you it was just those milliseconds, I guess, and for me it has been a little bit longer, but yeah, now let's see. We wanted to integrate this with the pixels thingy here, so this pixels crate. So I guess what we first need is pixels always needs something that it can use as a render context, like a window where it can render into. It's using WGBU in the backend. And let's see, let's go to the repository. Maybe they have some perfect examples, and let's see how they are doing that. So Conway invaders, minimal W init. Okay, minimal tau. Are we using the W init, or are we using tau? I'm kind of, I guess W init is the default. Yeah, that's perfect. That's exactly what I was looking about. So we're looking for. So first of all, what dependencies do we need? We need, holy shit, what amount of I guess we need pixels, and we need W input and something called W input helper. What the hell? Okay, let's take a look at the tau example, because I'm a fan of tau. Tau is actually, it's a fork, if I remember correctly, of W init, and it is used by the Tauri guys, which are doing this really nice kind of electron thingy in Rust. And example is based on using tau. Okay, so and I like tau a little bit better. Yeah, and we only need tau, so maybe we'll take a look at that. It's not that different, actually. So what are they doing here? They are doing something like, they have some sort of world. Okay, they have an event loop. Is that from tau? Yeah, it is. It isn't. Isn't it? So yeah, maybe we want to kind of copy first of all of that, because that's mostly the come on, raw. I want just the, yeah, perfect. So there we go. So let's more or less copy this code. Holy shit. Yeah, I guess this is all rendering example stuff. We don't know. I really we don't need. I really only want the initialization. So let's see that we can get this in here. So first of all, cargo add pixels. So now we have installed pixels, and cargo add tau. Okay, no idea what this actually is, but yeah, we will see. I guess that's our RWH. That most likely is raw window handle or something like that. It's what W init and tau use under the hood to get handles to your system's windowing stuff. Yeah, so let's see. I guess we can just kind of paste that function there and call it foo for now, and then we can just strip it of all the things that we don't need. We, I guess, want to import tau event loop. Yeah, I guess so. I guess we want, why the hell do we need a menu bar? Can we just I hope we can just leave it out there. So what is this logical size? Okay, DPI logical size. I see. This most likely is something that we need to specify to have the size as we could have something like a higher DPI screen, which then scales things up and stuff like that. Okay, so yeah. And then we have these pixels here. That is quite nice. Let's import surface texture from pixels, surface texture, and this is pixels new. With height, we will take a look at that in a second. Then we have the event loop. So this will be a tau event. This will be a tau window event, I guess. And this will be some sort of import tau, something like that. What's this control flow is from event loop control flow. Okay, so this is, let me read that in a second. Let me for now update internal state and request a redraw. Wait, what? Okay, so do we actually need to integrate our event loops? I guess we need to integrate this one into our event loop. Okay, we will see if we can do that in a general manner, I guess. Because we need to kind of wrap. We need to kind of wrap all our things around this, don't we? Yeah, I think so. So we don't need that. Maybe we just do something like update state here, and this is something like render, and yeah, this is something we don't need. Okay, so let's see. Let's take this step by step. So before we are even calling this and we are even creating our step, what we need to do is we need to initialize the window. So first of all, I guess we need this part. So let's put that there. So what do we need? We need an event loop, we need a width and a height. And this is something that okay, I see. So with inner size takes... why are we taking this as a float here? Does that make sense? Is logical size? They are all kind of... Wait, what? Okay, so let's do something like... I want something like width is... let's do something like 640 and let's height like 480. And then we put this in here, and I would actually height. I would actually assume that this would work as well. So why did they convert it to floating point? Okay, we don't really care. So we have this width and with height. We definitely need to transport this somehow into our loop later on, because we need to know it to draw into the pixel state. But let's see. So okay, so now we should actually have a window, I guess. Yeah, and maybe we should... Yeah, I guess we can fix it up using anyhow later on, because we should add a context here and then fail nicely. But yeah, let's see. So, and now, once we have a window, we want our pixels. So this seems to not work. We will see in a second. So pixels, width, and height. And yeah, I guess, and we do an unwrap here for now. So, and there is some problem with the surface texture. So what's the... Okay, let's... Wait, what? What's the problem with the surface texture? Let me see the full compiler diagnostic. So the trade bound window pixel is raw window handle has raw window handle is not satisfied. The trade pixels raw window handle is not implemented for window. Yeah, that might be some problem for this, what I said, this raw window handle stuff, because there are different versions. And the problem is that pixels might use a different version of this raw window handle, and therefore the trade is essentially a different one. That is something that I find quite strange about Rust. But let's just see if we take a look at cargo pixels. What the hell? Okay, cargo pixels Rust. There we go. Let's see what the dependencies. Raw window handle 0.5. And as we can see, we are actually here using 0.6. So we need to do cargo add tau minus f rwh05. And I guess we need to somehow, and I don't know, cargo add. How do we do that? In the command line, I don't know. So let's just disable the default here in cargo toml. So default features false. Yes. Thank you for completing that, Visual Studio Code. So now actually this should maybe be okay. So yeah, as you can see now it is okay because it implements the right trait. Sort of. It's kind of strange and a little bit broken, but it works. So what we are doing here is we are getting the window size. Yeah, kind of makes sense. We are taking that to create a new surface texture, which we are then giving to pixels, and so that pixels can render into that. Okay, that makes sense. So now let's see. What we have now left is essentially the event loop. So we need to take kind of this event loop and we call it in a loop because it's an event loop. And what they are doing here is they have some sort of keyboard event stuff for when we want to close that. I guess we can remove that for now. And resizing, I guess we don't want that either for now. So I guess what we want to do is some sort of something like that. And we somehow want to integrate that into our render loop. So let's think about how we can do that maybe in a generic way. Okay, before generalizing that, let's maybe do some hackery first, just to get things working and to have me get a better understanding of how this actually works, because for now I'm not 100% sure though. So what I want to do is I will copy this and I will just put it there, and I will call it pixel loop tau, and I will just hard code the tau stuff in here. So let's see. So what we want now is, where did I put all this? No, I wanted this kind of stuff. So I guess we take that out of there and we for now put it, up here. It's not the right position because, or maybe we can put it at the right position. We can put it essentially where the loop is, because that will be our new loop. So what we want here is event loop. Is event loop actually created on a window, or how is it? No, it's just is the event loop. Where do we use the event loop? Is it just a event? Oh, okay. The window is built with the event loop. Okay, then this makes sense. But then I guess we need some sort of we need something. We need the event loop, which should be a reference to an event loop, I guess. Let's do this for now because it is what is created, just to get it working. So now we actually have an event loop here. And now we want, I guess we need a window then as well. So let's get the window here. Which most likely will be a window reference, something like that. And we can't do that as well. Cannot find type wait. What is actually returned here? What is this? It is a window, so we simply did never import it because we didn't need it. And yeah, makes sense. Okay, so now we have a window there. And we need pixels. Yes, that's right as well. So we need pixels. And this will be a reference to pixels. And I guess most of them will need to be mutable in the end. But let's for now see. So if this actually happens, I don't want to do anything control flowy. Then I just want to panic pixels render error. Something like that for now. I have no idea what control. Oh, I have to take a quick break because the cat is quite hungry and wants something to eat. Give me a second. So there I am again. The cat seems happy now and is eating. Okay, so where were we? We wanted to kind of eliminate this control flow thingy here, and we wanted to. Yeah, we now kind of need to do this, I guess. Yeah, let's see. When do we... So the loop, I guess, essentially happens now for us between the renderings. So between the redraw requests. Let's see, actually, we have this. We have the event loop here. So this is where now this code lives. This is our new, our new loop here. So we will have to see where we need to put those things here. But for now, I guess this event loop is where our state lives now, where our loop lives now. So I guess we can do something like, in this case here, in this scenario here, call this call somehow this main events cleared. Update internal state and request a redraw. Yeah, okay, I see. So okay, so every time this happens, all main events are cleared. We are actually going to render and then we are updating. Okay, that kind of makes sense and it's okay for me. So we want to do that. But what is if this loop is run anyways and the main events aren't cleared? So when is this actually emitted? When all of the events loop inputs event have been processed and redraw processing is about to begin. This event is useful as a place to put your code that should be run after all state changing events have been handled and you want to do stuff, updating state, performing calculations, etc., etc. That happens as the main body of your event loop. If your program only draws graphics when something changes, it is usually better to do it in response to event redraw requested, which gets emitted immediately after this event. Programs that draw graphics continuously, like most games, can render here unconditionally for simplicity. Okay, so we actually, I guess, maybe don't even want that. Because we kind of want to do that. And then, yeah, then we, actually, then we need to do all of this calculation there as well. So actually, this part of this event loop now is our complete loop from before. So yeah, I guess this could work. So let's maybe remove this one here. Let's call this one pixel loop tau. And then what did I need to put in there? Yeah, I needed to put in there. Come on, give me some hints of what I'm missing there. Let me see. How did the ordering? I wanted the ordering. Event loop and window and pixels. Okay, so what we are putting in there is, where am I? Event loop and window and pixels. And now we will see what I need. Expected reference pixels, found reference to nothing. Wait, what? Oh, it's because I have a semicolon there. And now everything's broken because something. Parameter S may not live long enough. The parameter type S must be valid for static lifetime. What the hell? Why? Because I'm moving it into the event loop? Yeah. I guess we can do that. I guess I can live with that. Okay, so what's the next problem? Pixels is a reference, but is only valid in the function body. Wait, what? Borrowed data escapes outside of function pixels. Let's call the lifetime of this reference 1. Yeah, okay. Pixels is a reference that is only valid in the function body. So pixels escapes the function body here. Arguments requires that one must outlive static. Yeah, because we are moving it into this event loop function, but okay, isn't there another way to what's with this run thingy? It needs static and this is an fn mut and yeah. Okay, so maybe we can, I have to think about this, but maybe we can do something like this for now. And then we have another one. What is the problem here? Pixels does not live long enough. Yeah, it essentially does, but you don't know. So how can we fix this up? So the static thingy isn't working out for me here. So maybe I can fix this by, for now. Yeah, I don't really like that, but for now, maybe we move all of this into our looping function here and just do something like put this stuff here so we don't need to supply it. Yeah, and now of course we need width and height. So that's thing actually we can do. Let's take that as a I don't know, height. No, width, height, usize. Let's get that as a tuple. And so this one's happy. So let's initialize that here. We don't have those anymore, but I just want with height there. Okay, so what's the next error here? We don't need this anymore. We don't need this anymore. What's the next one? The trait-bound usize pixel is not wait, what? The trait-bound usize pixel is not satisfied. The following other types implement trait pixel. Required for size to implement from logical. Okay, is this the reason why? Yeah, then let's just take it as a whatever, U32. That was the reason why they kind of casted it into an F64, I guess. Used isn't initialized, used here, but it isn't initialized. Wait. Yeah, but okay, instant now. Shouldn't actually really care about that. Value captured is never read. No, yeah, that's why I yeah. I don't know. Let's just ignore this for now, and let's see. Does this actually work? No. Does this compile and create a window cargo run? Oh, it has to. Oh, holy. Yeah, it's using a lot of different dependencies, I guess. So let's quickly compile all that. It's using a lot of different graphical stuff, and Tau is using a lot of different stuff as well to communicate cross-platform with Windows and give you events and stuff like that. WGPO is most likely there. Okay, so wait, I'm not 100% sure what happened. Oh, I know what happened. I forcefully kind of resized the window due to my tiling window manager thingy here. So yeah, can I actually, what happens if I quit that? Yeah, okay. So we can create a window. So let's see if we can actually do something and draw something on it. What we need to do though to be able to draw something to it would be to provide it with a reference, and therefore a mutable reference to pixels, I guess, during the render call. And do we need it during the update call? I don't think so. So let's adapt our pixel loop tau function with a render call, which now takes a mutable reference to pixels. Or do we even need a mutable reference to pixels? The question here is, first of all, does this work? It does work. So yeah. So first of all, I guess now we can, I guess, remove the sleep thingy here, because we are actually doing some rendering work. What was the time actually? So yeah, as you can see, that is because we are doing some rendering work, and now it's limited to our display refresh rate. So yeah, let's see. Let's do something with the pixels here, I guess. So if I remember correctly, you need to do something like above pixels. There was something like get or pixels, no. What was it called? Frame mut, and this will actually give us the frame buffer that we can actually draw something into. And yeah, I guess first we will kind of clear it, but yeah, we need. Do the pixels give us a size? Let's see. Do we have something like size or come on, no. Surface, maybe surface texture format, resize surface. I don't think we easily get that. I have no idea, but let's just width and height, let's just put that in there as well for now. So where was it? Tau. No, I want the, come on, where is the, there it is. So we can put that into it. Where do we call render? That we call render. With height, we just give it the information, I guess. It's not working anymore. Why is it not working anymore? Unexpected argument of U32. Expected 3 arguments, found 5. What did I do wrong there? I had to adapt it here as well, didn't I? render, yes. So U32, U32. So now this should give me the size. So let's do something like for y in 0 to height. Do something like for x in 0 to width. We want to do something like bada-boom, bada-bam, buff, or let index. The index into the data would then be the row times height plus x times 3, I guess, RGB. Expected semicolon, yeah. Absolutely. So, and let's call this I and not index. And let's then do something like buff I plus 0. This would be the red component. Let's do this, and let's do buff I plus 1 would be the green component, and buff I plus 2 equals 0. So essentially we should now have zeroed, so made it black. So have zeroed out the background, and as usize, I guess you want it because I'm using it as an index. Where's your problem? Missing, whatever, what? Wait, what, why are there 2 of those? Come on. And how I have just deleted this B here. Okay, so now we have cleared the background, clear background. And now let's do something like, let's just create a moving pixel. So let's do something like, yeah, where's our state? Let's put something in our state like pixel position or something like that. Position, and the pixel position will be something like a usize. Yeah, I guess that is okay. And now we can do something like buff s dot pixel position dot 0 times the width plus the height plus s time, we are having x first, so I need to do s here because that's the y coordinate, and then s pixel position dot 0 is then there. And yeah, maybe we should we can just do 255 for this specific as usize for this specific byte there, because then it will be red. Okay, so so we are essentially rendering a red pixel at this position, one single pixel. And if I now run that, it should actually give us a single red pixel in the upper right corner. And of course we can't see that. Yeah. Okay, maybe we should do something like maybe we should do something like, maybe we render a rect there or something like that. So let's do something like for y in s dot pixel position dot 1 to, let's say, 50. So we are using it as the upper left corner of the rectangle, and for for x in s dot pixel position dot 0 250 do something, and we can essentially borrow that and set those pixels to, let's say, 255, 255. And again, what is the problem here? Wait, what is the problem? 232, because the Y is a, I see, as U size. Yeah, so this should actually work. We can remove that, and then we should actually, yeah. I did something wrong. This looks like actually like the pixel format has an alpha channel, so I actually need to calculate that with 4 components, I guess, and I guess I want to set then buff I plus 3 equals 255, I guess. Not sure actually why the rendered background, okay. Still not right. So can we get out of this thing somehow the components of the surface texture? So what is going wrong here? Let's take a look at the at this example I stole this from. They were kind of rendering a box or something. How were they actually rendering the box? So yeah, they are actually rendering. Oh, that's a nice idea. I didn't know you can do that. So for iPixel in frame chunks, so they are actually enumerating the pixel thingies, but they are enumerating in pairs of 4. So yeah, that's fine for me as well. So what I'm doing should actually be okay. So, and then they are setting those values. So yeah, so it's a 4 component thingy, and this is the alpha transparency, and yeah, that's okay. It makes sense, but why does this not work out for us? Where is my? It's most likely it's a completely obvious error that I'm making there, and I don't see it. So what are we doing here actually? We are going pixel position to, so 50 by 50, that looked right to me, and then there was something. Does this thing have some sort of stride or something? Maybe? I actually don't know. Does it have a stride? Okay, let me do something like frame mut. What actually do we get? A mutable byte slice for pixel buffer. The buffer is not cleared for you. It will retain the previous frame's contents until you clear it yourself. Okay, and it's simply a U8 slice, which makes absolute sense. So the problem here I see is examples. Yeah, for frame, they are all iterating but I don't really want to do that. I want to, yeah, maybe that this iterates over the stride, kind of, but I don't. Wait, no, wait, it's iterating frame mut. So it is essentially iterating the byte array. So it is, then what we are doing here should, why doesn't it work? Wait, did I just, come on, let's try this again. Cargo run. Did I do something? What the hell did I do wrong there? That is so clearly broken. It must be something real obvious. And I guess you all are just crying at your, screaming at your screens for me to. Oh, yeah, I see it. I multiplied the index with the height, and I should have multiplied it with width, of course, because for every row I create, I need 1 full row of pixels. Come on. Okay, now we have a yellow square there, which is quite nice. So now let's try and animate that. Like, now we need to do something in our update function, don't we? And now we should do something like, I I guess we don't need that sleep anymore. And let's do something like s dot, what did we call it? Pixel position. Yeah, it doesn't make really sense now. But let's move it. Can we actually, let's do something like, wait a second, pixel position, and I want, let's call this box position, and let's do something like box direction. And you will see in a second what I'm doing here. It's an I32 or an I size, can be an I size as well. I just need 1 or -1 there. So, and I guess now, damn, now I need to implement the default myself. So impl default for state, because I need a specific state there that will not be, that will otherwise not be correct. So box direction should now be 1, 1. And maybe we can even do something like box size and do something like make it 50-50 here, and we call this one box size, which is a U size, just to reflect the dimension here. So okay, and what we need to do now is we broke something. We broke, yeah, something that I never typed to the end. So okay, so what I now want to do, I want to just move it. So box position, box position dot 0 is the x coordinate, should be plus s box direction dot 0. S box position dot 1 should be plus x box direction dot 1. Yeah, which kind of can't work, because can we do something like add checked add? No, yeah, maybe, not sure. Wrapping add. Okay, just for the simplicity of it, where's our state struct? Ah, come on, where did we define our state? There. Let's just put the position into an I size as well. We will see in a second why this is interesting, and we will fix up the errors later. So what we want to do now is we want to update box position 0 equals as box position 0 plus s box direction 0, and we want to say the same thing we want to do with this one and this one. And now we are doing the following: if s box position 0, and we don't need the braces, is bigger than width, is bigger or equal than width, wait, if box position 0 plus s box position box size 0 is bigger than width, or come on, or s box position 0 is smaller than 0 now, then x box direction equals as box direction 0 equals as box direction 0 times -1. So we kind of flip it. And why is all of this red now? Expected pointer for an input found closure. Wait, what? Oh, because I took the width? No, I'm getting the width from here. I see, this update thingy doesn't get the width yet, so I just want to get that here. Yeah, we need to fix that, of course, but okay, so if this is the case, and then I want box direction 0 to be as box direction 0 plus as box direction dot 0. So we are going box position, of course. Box. So we are moving into a proper position there again. So something like this, and we need to do the same for the box position 1. So everything that is 0 in here should be 1. Yes, so but not that one. That should stay 0. So yeah. And now we need to put into this one, we need a U32, and when calling it, we actually need to do something like, come on, with height. And now let's check the errors. Where is an error? Here is an error. Expected eye size, found U size. Yeah, because... yeah, come on. Width needs to be an eye size now as well. Yeah, as eye size. The values are all too small to cause any kind of problems here, I guess. Okay, so... oh, the doorbell. Just a second. Okay, so where were we? We had some error here. What's the problem here? So, expected eye size, found use size. What? Wait. Why? Box... oh, because we're iterating the box position, and... maybe we should do something like as U size, because the box position should always fit into that. Otherwise, we have made a very, very grave mistake. So, yeah, so now let's cargo run. And then actually this box should bounce around. It doesn't actually. It was there and then it wasn't. Wait, what? It looked kind of cool, but yeah. Where's our render function? Render? No, it's not called render. It's somewhere down below here. So our render is called SBox position. Oh, I see. We need to do something like as... oh, interesting. Yeah, we need to go from box position 1 plus X box size 1, I guess. Yeah, we will fix up the typings in a second. As box... come on, box position 0 plus S box position 0. So, no, size 0. And now what's wrong with the typings? Yeah, font eye size. Yeah. Okay, so let's do something like that. And let's say as U size, because those two together... oh, okay, as U size. I don't need the braces. I thought I'd changed both of them to be eye size. So let's just do as U size. And now, maybe this box should bounce around. No, it crashes because we are going out of index. So somewhere my calculation was wrong, but it was moving already. let's see, where do we calculate the update here actually? So the problem there is that we are wandering out of if the box position plus the box size is bigger or equal to the width. Yeah, and oh, this should be height. There we are. So let's see. Now it should maybe bounce. Bing, bing, bing. Really nice. And really, as you can see, at a really constant moving speed. And this is essentially what we wanted. So maybe let's make it a little bit faster. Let's maybe go and say we want, where is our default? We can do 2 and 2, and now it should actually run as double. Yeah. And now let me take this window and maybe move it around a little. Can we somehow, I guess it's a little bit a problem to make the rendering speed less, but yeah, as you can see, we can actually, I guess we can actually simulate that. We can actually maybe, yeah, we should be able to make the rendering slower. Let's see. I could actually, what happens if I'm doing something evil, if I'm doing something like I'm waiting in the rendering function like std thread sleep duration from millis, and let's just sleep there like 20 milliseconds, then we shouldn't be able to render at 60 frames. It should, yeah. And as you can see now, the rendering speed is now a lot less, but we are still getting around the, as it's fluctuating so much, but around the 120 updates per second. And as you can see here, the square is still moving at the same speed. It's a little bit more janky because we have now a little less frames per second, and we are a little off. That's kind of the thing I talked about, this movement smoothing we would need to do. Yeah, maybe we can do that in a second iteration or something like that when we make it more generalized. Don't know yet. But yeah, for now I'm quite happy. I need to think about how to generalize this. So I guess there will be a second session to this. But for now I'm quite happy that I have implemented that. And once I've generalized and cleaned it up a little, I can actually use it for things to come, which I'm looking forward to. So yeah, I hope you enjoyed it as much as I did. It was a little longer session again, but yeah, I guess it was worth it. So I wish you all the best, and if you liked it, please subscribe and hit the bell and be notified when I do more like that in the future. So see you in the next coding session with Mr. Jacob. Bye.